Hello, welcome to the course of IPv6. So today we are going to discuss about QoS, that is the quality of service of the IPv6 packet. So in this class we will discuss about what is QoS and then the architecture of QoS and the flexibility in IPv6 header. So let's start with the first, that is what is QoS. So here the QoS, according to the basic IP model, all the packets in the network are treated similarly. That means all the packets are forwarded with the best effort according to first come first serve principle. So here the quality of service plays an important role. So here the quality of service will help in transmitting the packets as according to first come first serve principle. So to meet the demand of assessing real-time service efficiently, IPv6 provide a QoS feature. So QoS protocol have the task of providing different packet streams with priorities and metrics such as bandwidth, delay, inter-packet delay variation, that is also known as jitter, and the packet loss. So these are the parameters that are considered by the QoS protocol. So next we are going to discuss about the architecture of QoS. So QoS protocol consists of two main architecture, the integrated services and the differentiated services. So here both the services use the traffic policies and provide quality of service feature in both LAN and WAN network. LAN is local area network and WAN is a wide area network. So here the traffic policies are used to make transmission of data depending upon the various rules. So let's start with discussing first architecture, that is integrated services. So here these architectures offer a capability to allocate bandwidth to different flows. So here this architecture will define a bandwidth to different packets that are flowing in IPv6 network. So in this architecture, routers stores the information about the flows and it analyzes each packet separately. So based upon the model that provide assistance from end-to-end connectivity during the transmission of IP packet. So resource reservation protocol, that is defined in RFC 2205, it is a part of interserve architecture and it is a signaling protocol that is used to reserve bandwidth and other quality of service resources across on IP network. So this is about the integrated service architecture and it doesn't provide scalability to a network. The next we are going to discuss about the differentiated services. So here this architecture is designed to provide scalability and usability in large network and internet. So here there are some parts in this. First one is the DS domain. So here this DS domain is a neighboring group of routers having similar service policies that is implemented on all routers. So the boundary routers classify incoming data packets and label all the packets and use a peer hop behavior for all the packets. And after that the next part is DS region. So DS region is a set of neighboring DS domain and here it ensures the DS service for all domain spanning path. And last part is the packet classifiers. Here it checks the packet header information and it chooses the packet from the data network and it checks the packet header and verify according to the predefined rule of defining headers. So these are the part of the differentiated services: DS domain, DS region and the packet classifier. Next we will discuss about the type of packet classifier. So there are two types of packet classifier. The first one is the behavior aggregate classifier, that is defined as BA, and it classifies the packets based upon the DS field, that is differentiated service field. And after that multi-field classifier, it is defined as MF and it classifies the packet that based upon the different header fields, and the header fields are such as source address, destination address, the DS field, protocol numbers, source or the destination port information, and the incoming over to the incoming interfaces. So these are the two type of packet classifier in the differentiated services. Next, we will discuss about the different fields in IPv6 header. So there are two different fields in IPv6 header. The first one is the traffic class field. So here the IPv6 offers flexibility as well as it support different quality of service mechanism by adding functionality in IPv6 header. So first of all, here in traffic class field, it will consist of two fields such as DHCP and the ECN to provide the flexibility. So DHCP is the differentiated service code point. Here it defines the real-time data streaming application, and it is used as this application will use the quality of service protocol, and the example of this is VoIP, that is voice over IP application. And next is the ECN. ECN is the explicit congestion notification. Here it carries information about the network congestion and it allows the end-to-end connection without packet dropping. The next part is the flow label field. Here the flow label field is used by the source to label the packet. So here basically a flow is defined as a sequence of packet from a sender to a specified unicast, anycast or the multicast address labeled as a flow by a router. So here the value, its value ranges from 00001 to FFFFF. So here it is practically not used. We only use the traffic class field. So it is used for giving real-time application services and also help to detect spoofed packet, and this field requires the router to efficiently handle the packet. So these are the two different fields in IPv6 header. The first one is the traffic class field and another one is the flow label field. Most of the time we use the traffic class field and the flow label fields are not practically used. So this is all about quality of service in IPv6 packet. Thank you.